So what we were able to do is to go out to an online auction site and buy 2 machines. Less than $100 is the cost of entry into your exploitation and vulnerability research. So this is what the machines look like when we booted them up. They're fully assembled. So now what we'll start to do is dissect them and see what we can find out as far as exploitation vectors. So I've only had access to this for a few minutes. I mean, literally a few minutes. And I can already see the threat landscape of this machine. I have a DB9 port here. I see the chip for the operating system is not glued in. Pretty carefully, I can pull that out. Now what that's going to allow me to do is to leave the machine behind, and I'm going to take this chip and put it inside of my reader writer and start looking at what's installed on it and what the OS has for exploitation potential. Another thing that's disconcerting to me with this is that this is the smart card, and on the back side of this I can see that the communications cable is not secured either. And that would allow for someone to put a shim in here. If someone wanted to install a defeat device, they could put it right here and then plug it back in so the smart card would function as normal, but it would change information as it goes in. All the model numbers are on these chips, which really they should have been removed or redacted or ground down. I mean, I can clearly see that this has 1 gigabyte, so I'm assuming that that is probably on the cache side of it. We have way too much information on here. All of these here start to have a piece of the puzzle that you can put together to start formulating your exploitation vectors. So what we have here is a smart card, and this is from our Hack the Vote initiative that we did. In this particular machine, there's 3 different cards. One's a supervisor card, the other is the actual voter card when someone goes in to vote, and then there's a 3rd card as well. So what would happen is that the person inserts the card, and we're going to see that it's not reading our card because we've yet to load it with the code. But the fact that it is detecting it is kind of interesting. We're going to look at some system logs. First of all, what strikes me as being interesting is that this is saying that it's using OpenSSL. It gives the version number, which is bad because if there are any exploits into that, then we know exactly what version it is. We can see that there was an administrator card that was inserted, and then it had the original date and time, and then we'll see down here where the date and time was set with the administrator card. Now, what's disturbing about that is that if this machine was to be booted up before the election day, someone could insert an administrator card and then pre-populate some votes. We see down here, this machine's actually done 1,434 votes from what we can tell. So with this, it's just kind of disturbing that someone could change the date to either close the precinct a few hours early or maybe pre-populate with some votes. We don't know quite what precinct this came from because it just says Stark County. So we're just going to see if we can find any other information in here. So what we see here now is 122 Myers Lake A, maybe Avenue. And that M Lake _ Can, don't know, maybe Canton, Ohio. And it says Party Democrat. So it says that there was a card created, and I guess maybe they are tracking the card is for a Democrat or maybe some other party affiliation. So just having the precinct information, now I know what machines are being used in the precinct. So like I said, we have 2 different style voting machines, but we know for a fact that that precinct possibly uses this style. So if I'm going to exploit that precinct, I'm going to do it with this style machine. So that's some pretty good information. So if we look through here, whoa, what is this? What is this? Yeah, this isn't good here. So apparently something, let's see, something through this error. And with errors, you get a lot of information that could help. All right, so this machine error log was written on March 2013. However, this error was thrown in 6/11/2012. So to me, I would be looking at when the election happened. Did this error come before the election, during the election day, or after the election? But looking through here, there's a lot of information that we can gather. We see things like winstock.dll, so we know there's some communications that can happen here. Toolhelp.dll, all of these are DLLs that are associated with Windows components, but what that will allow us to do, things like with taskmon and stuff like that, is to see, are there any exploits into these sub-processes? If so, it may lead to exploitation inside the machine. We also see that it's probably the main program is this ballot station.exe. We see a lot of those in there. So all these error logs are very good clues to what's going on. And the one thing that we found that was interesting was a little bit of clear text in here is TAHOMA. So not sure what that is. Maybe we will look and see if there's a candidate with that name or something, because that could let us know what was being displayed on the screen at the time the error was thrown. So you could imagine if someone had an exploit into this, and every time someone tried to vote for that candidate, it throws an error and says, vote tabulated or stuff like that. So all of these things are telltale signs into what's happening with the machine. And with this error message, I'm going to research further and see if I can deduce what actually happened when this error message was thrown. So what we have here is the what they call the security status, right? And so here is the key hash where you see that they're using 128-bit AES encryption, which is good. But the one thing that's a little bit on the disturbing side is that this key has expired in July of 2013, but the issuer here doesn't appear to be one of the major issuers of certificates. Not saying that that's horrible, but that means whoever issued this ticket, the whole integrity around the communications and the encryption on this device resides on where this private key is. We don't know if this is on somebody's laptop that could be stolen. We don't know if this is inside of a secured air-gapped network, as most of the certificate authorities are, and stuff like that. After looking at this for the limited time, and looking at the amount of information that this device has given us, that's not necessary. And also, all this information is being gathered without us doing any kind of exploitation. We showed you a few things that we would start looking at, but the fact is that this machine booted up and presented us this information is a little bit disturbing. This is yet giving up more stuff. So we see that it says data transfer over SSL and TLS. So we know that there's some IP-based data transfers that can happen. We showed some communications chips on there. We see that there's user-defined security keys and supervisor pins. User-defined. That means that probably these devices, these pins are set once they go out to whatever district it is and stuff like that, because it says it's user-defined. So yeah, there's a lot of stuff in here that is worrisome. And I'm pretty confident that with the amount of information this machine gives up, then we could develop a exploit into this, given how wide the vectors are and the landscape. So the first thing I would do is have a plan pre-formulated. And since the election data is housed on a glorified thumb drive, type thing, I would look at manipulating it that way. So it would be a simple, I walk up, I have my key for this, I pop something out, I put something in. That would be the vector. So the one thing that I am happy about is that this machine was for sale online. So hopefully this precinct has updated their machines. However, this same machine is probably one that's being used in one of 9,000 other precincts around the US.